Okay, all right, so let's go ahead and go over our notes. Everyone should have picked up a purple and a yellow piece of paper. A purple and a yellow piece of paper. All right, look for the one that says conics. See this dotted line right here? You are going to fold on that dotted line. Okay, so I'm folding on that dotted line. Boom. So I've got this little flappy situation here. Okay, I'm looking at the one that says parabola. I'm going to fold that down. And notice there's a dotted line there. Okay, so you should be able to see ellipses and parabolas. Find that dotted line and give it a good crease there. Okay? So I see ellipses and parabolas. My parabolas are on the inside. There's a dotted line up here that I gave it a good fold on. Help your neighbors. Some people are folding challenged. Help your neighbors. I took the one that says parabolas and I folded it down toward the other parabolas. So now I see ellipse.
It's a parabola.
Okay. Parabolas.
No.
Now take your yellow and put it inside purple.
This is not lined up right.
It does line up. It's
No,
fine.
no, it doesn't.
It's fine.
That's pretty good.
See, because like now it cuts this part up.
That's called Coach Cleveland.
I'll take that.
Cleveland.
I mean, I really do think you'll be okay even if it's not perfect. Okay, cool.
Where's that top? What paper?
If you need the top one to be a little bit longer, then put the dotted line on the back a little bit.
Yeah, but then it cuts off the purple part.
Oh Lord, child, I'm going to tell you that. All right, I'm going to pass around a stapler. I'm going to give it one little staple at the top.
Yeah, and you can't see.
There's one back there on Anthony's desk.
Hey, we're folding challenge around
So
this
go
part.
give it a little staple and then pass that stapler around.
Don't know what's happening.
So this is what it looks
The
like.
yellow inside the purple.
Oh, okay.
We're going to kind of fly through this. This is solely meant to be a review. If you've been absent, here's your crash course. If you haven't done your work by staying caught up on Canvas. Christina, is that still going?
Yes.
I gave it one little staple up here so that the insert didn't fall out.
I need
All right,
a stapler.
I am putting up the first flap. Please join me on ellipses.
Yeah, they're never straight.
If you, listen, my OCD children, you're gonna be fine.
This is not okay. You can't even see half of my hyperbole.
I know.
All right, or you can review yourself. I'm over it.
I'm thinking about it.
All right. Standard form of a horizontal ellipse. X minus h squared over a squared plus y minus k squared over b squared, it equals 1. The vertical, x minus h squared over b squared plus y minus k squared over a squared still equals 1. How can you tell whether the ellipse is horizontal or vertical? After you all getting confused about which one's a squared and which one's b squared today, I'm going to make you forget about a and b, hopefully. Okay? Larger number under x, that's a horizontal. Okay, if the larger denominator is under the x, it's a horizontal one. If your larger number is under y, that's a vertical one.
Where did you find the Disney text? Do you have to like download it?
Yeah,
Oh man.
it's pretty easy to install fonts.
You gotta pay extra for it.
Nah. Yeah. Fontface.com. FONTFACE.
You didn't make this Foldable though, right?
I did not. I stole it from another teacher here at Timber Creek,
Which one?
Miss Anzeldua.
Huh?
Miss A. All right.
How?
How- Sure. As long as it's not a bad word, you can call me whatever you want. All right. How do we calculate the distance from the center to the foci? Okay, that's your C value. I don't want you to get hung up on anything. I want you to just do bigger squared minus smaller squared. I don't care if we're calling it A or B anymore, just the bigger one, the bigger denominator minus the smaller denominator. And if both of these denominators are exactly the same length, what shape do we actually have?
Circle.
A circle. Okay, very good. Right, all circles are ellipses, but all ellipses are not circles. Just like all squares are rectangles, not all rectangles are squares. Okay?
Well done.
Wait,
Alright.
why are squares?
Squares are four-sided polygons with four right angles, such that opposite sides are congruent. Squares, all sides happen to be congruent. Okay, here we go. Let's label all the beautiful pieces here. What do we call this point right here?
Center.
Nope.
Center.
Center. The endpoints of your major axis,
Vertices.
these are your vertices. Here's a vertex, and here's a vertex. Together they make up the vertices. That longer axis is your major axis. If you want to label it, I'm not going to. These points that are also on your major axis, what are these?
The foci.
These are your foci. Here's one focus, here's the other focus. Together they make up the foci. Why do I say it like that?
Because she's delighted that
That's
it's
how
a
the cool
wonderful
kids
day.
say it, Mackenzie.
Do you have like
We're
a
not.
The major axis is the longer axis, the whole thing. And what do we call these points on the minor axis?
Co-vertices.
Co-vertices. Here's a co-vertex, and here's a co-vertex. Together they make up the co-vertices.
Uh-huh.
That was especially for Mackenzie right there.
You don't have to dedicate that to me.
That was a shout out to you.
I don't have to do that. It's okay.
The distance from your center to a vertex is A. The distance from your center to a co-vertex is B. And the distance from your center to a focus is C. Right, so I haven't taught you anything new today. It's simply just going back and kind of collecting all the pieces that we've learned. All right, let's do an example. Right off the bat, I'm going to eliminate A and B. I'm going to say left and right, and I'm going to say up and down. I don't care about the letters. I don't want y'all getting confused just because you don't remember which letter's which. We're just going to call it the left and right one. We're going to call it the up and down one. All right, where do I find my center?
HK.
In the parentheses, right? So to find the x coordinate, you go look and find the x. It's always opposite. So what's my x coordinate here? -1. What's my y coordinate?
3.
So my center is -1, 1, 2, 3.
Are we forgetting A and B now?
We're just doing left and right now.
Okay.
Now, whatever is underneath the x is how far you travel left and right. I don't care if you're calling it A, I don't care if you're calling it B. It is your left to right movement because it's with your x. So how far left and right am I going to go?
5.
5 units, right? The square root of 25, 5 units. I don't care what letter you call it. We're going left and right that much. So from your center left, 1, 2, 3, 4, 5. And right, 1, 2, 3, 4, 5. Yes?
Yes, ma'am.
I don't care what letter you're calling it. Whatever the denominator is underneath your y is how far you're traveling up and down. So how far am I traveling up and down?
2.
2. The square root of 4 is 2. So starting from your center, go up 2 and down 2. As soon as you have your vertices and co-vertices drawn, you can draw cute little ellipse. So cute, little baby eyeball. That was weird. Sorry.
Mm-hmm.
Aren't you recording this?
Yeah.
Everybody's gonna see that.
I do equally weird stuff in all my other classes. It's not just for you guys.
Are you sure it's recording?
Christina?
It is.
Yeah, she's be my helper. All right, so which set of points are my vertices?
Left and right.
Left and right, right? Because they're on my longer axis. So I have a vertex, yes?
4, 3. And
1, 2, 3, 4, 3, okay. And
Wait, why is it 4?
and then negative
4,
6, 3.
3. And then negative 6, 3. Remember, I don't care what order you put them in. You can do left, right, or right, left. Just make sure both of those points are listed under vertices. Which one are my co-vertices?
The up and downs.
Up and down because they're on the shorter axis, on my minor axis. So what are those?
-1.
-1, 5.
Okay. How do I find my foci?
You
Your
gotta,
C.
You gotta find C.
I've got to find C, right?
yeah.
If this equation has a plus, what equation does my C have?
A squared plus B squared.
Minus. They're always opposite. C is always opposite of what's given. So here it's the bigger one minus the smaller one. Well, everybody go type in what is the square root of 21.
25?
What would you say?
I don't know.
Hey,
4.5.
get it together. Get your calculators out. What's the square root of 25 minus 4?
4.58, so 4.6.
4.6. Y'all just sit here and making me do all the work. Ooh, children.
Talk about good.
So, which way do my foci go?
Left and right.
Left and right because that's my major axis. I'm going to go left, 1, 2, 3, 4, and some. And 1, 2, 3, 4, and some right. So this is the point 1, 2, 3, 4, 5, negative 5.6, 3, and 1, 2, 3.6, 3.
I'm a little bit confused
Where'd I lose you?
on that part.
Were you with me when I found the C?
Can I say no? Yes.
You're. I don't. This is not instilling any confidence. The formula. Look right up here. To find C for ellipses, it's the bigger one minus the smaller one. Okay. So here I did the square root of 25 minus 4,
Oh.
and that's how I got my C. And your foci always go on your major axis, so toward your vertices. So just go left by that amount and right by that amount.
Yeah.
4.6, okay? And so then I just calculated where those points would actually be. Negative 5.6 and 3.6.
And you start from the
See?
center.
1, 2, 3, 4, 5.6, negative 5.63, and 1, 2, 3.63.
Okay.
I just want to make sure it makes sense. You
It
count.
does not make sense.
You count from your center.
I feel like it's civil concept, I'm embarrassed. Okay,
You count from your center, left by C and right by C. So
Yes.
1, 2, 3, 4.6. 1, 2, 3, 4.6. But to tell me what the coordinates are, you still start from the origin like normal. Negative 5.6 and 3.6.
I got it.
Okay. Questions on ellipses? What do you have for me?
It's horizontal.
Thank you. It is horizontal. Thank you. How are you doing
Because the
when I was
bigger
doing it?
numbers under the X.
I was doing the map thing, I didn't feel like the A is equal to the distance. from-
What? Cooper? What?
She's saying how is it horizontal? I just see all that.
Okay.
So
Okay.
for your A, it's always left and right, and for your B,
No.
no?
See, I don't want y'all to get, underneath the X is how far you travel left and right. So underneath the X was 25, I travel left and right 5.
Okay.
Underneath the Y is 4, so I travel up and down 2. Don't get hung up on what's A and what's B. Okay?
So whatever's under the Y.
Goes up and down. Whatever underneath the X goes left and right. Every time on all of them.
Okay.
So I'm gonna just quit calling them A's and B's. Alright, parabolas.
Oh my god, that's easier.
Parabolas. Vertical. If it has a vertical, if it has a vertical axis of symmetry, then here is its equation. If it has a horizontal axis of symmetry, then here is its equation. How can you tell if a parabola has a vertical axis of symmetry, i.e. it's opening up or down,
The 4.
or a horizontal axis of symmetry, meaning it's going left to right? If the x is squared, it has a vertical axis of symmetry. If the x is squared, you know it's either opening up or it's opening down. If the y is squared, then you know it has a horizontal axis of symmetry. It's either opening left or it's opening right. So far, is this helpful?
Yes.
Am I wasting your time, or is this a good summary?
No, it's good.
summary.
Okay. Tried to pick an idea that would or something that would pull it all together for you.
Honestly, if we did this at notes, it'd be a lot more simple.
I think it's only easy right now because you've already seen it. This is a good way to go back and organize it. That's why I didn't start with this.
Fair enough.
Okay.
I like that answer.
It's always validating me. It's
Thank you.
confusing me.
Okay, how do you calculate P?
4P equals.
Set 4P equal to constant with, and I called that, remember, not squared. Go look on the not squared side, and that constant in front is the one that you said equal to 4P. Once P is calculated, how do we know which way the, yes sir?
I think we should write down the equation example next to it, because I don't think many people are going to remember what that means when they look back at their notes.
Hold on, what?
When you set 4P to constant with not squared, we should write an equation example next to it, because I don't think many people are
Or
going
you
to
just remember all the
Yeah.
8.
You can. We're gonna do one down here. So hopefully it'll make some sense. But remember, you add whatever you need to your notes to make them make sense to you. So if you need to go in there and add an example or say see example below, or you do you. Once P is calculated, how do we know which way it opens? Here's a quick guide. I did this for a kid yesterday. He's like, why didn't you just say it like this? And I was like, because I'm the worst human ever. Sorry. If the x is squared and you have a positive P, it opens up. If the x is squared and you have a negative P, it opens down. If you have y squared and a positive P, which way does it open? Right. If you have a y squared and a negative P, which way does it open?
Left.
So there you go. There's your cheat sheet. Right, up and right are positive, down and left are negative. Once P is calculated, how do you find the focus and the directrix? All right. For the focus, go into curve by P units. Okay, so up here, if I'm calculating P and it opens up, I'd go up. If I'm calculating P and it opens down, I go down. Over here, I'd go right for my focus. Over here, I'd go left for my focus. Okay, so just go inside your curve. How do I find directrix? Go out by P for directrix. Go out by P for directrix. I see some of y'all like, sit closer if you need glasses.
I put glasses at home and I did move closer.
Sit closer, nerd. You're not the only one. Not a good look. Not a good look.
What?
All right, let's label all the good parts. What is this point right here actually on the curve?
Center? No.
Christina?
Is it? Was that right?
Say it.
Center?
No, you had it right the first time. You said vertex.
Oh, my bad.
Vertex is the thing that's actually on the curve. What's this point inside the curve?
Okay.
That is your focus. What is the line outside of your curve? Directrix. And what is the line that passes through your vertex and your focus that splits it in half?
Axis of symmetry.
That's your axis of symmetry.
How do you spell symmetry?
SYMETRY.
So the axis of symmetry always goes through the vertex?
Always passes through both your focus and your vertex. Every time. And it's always perpendicular to your directrix. All right, P represents the distance from the vertex to the focus. The vertex is equidistant, meaning it's the same distance from the focus and directrix. All right, let's jump into an example. All right, here we go. Now, looking at this, I automatically know from the equation which way this is opening. I see that I have a y squared, and this value right here is positive. So where do I have a y squared and a positive p-value?
It's opening right.
And it's opening to the right. So I know right off the bat that this guy is opening to the right because the y is squared and this 4p value is positive. All right, what's my vertex?
2, -3.
Ooh, got
Negative.
him. I got a few of you. I told you that's where I was going to get you,
Oh yeah, it's -3 too.
right? That's the y value, guys. What's the x value?
-3.
-3.
That's what people said.
Oh, a lot of people said 2, -3.
Come on, fellas.
And the y coordinate is 2. I'm telling you, that's where I'm going to get you. Prove me wrong.
We gotta get it together.
I just did.
Huh?
Just like that.
This is unacceptable, Buckaroos. Unacceptable.
Thank you, Ivan. Yes.
Carouse.
All right, so let me go plot -3, 2. And like I said, I don't care how wide you make it open, how narrow you make it open. Just make sure it's opening to the correct direction. All right, how do I find my focus and directrix? I gotta find P.
4p equals 8.
So 4P equals the constant in front of the naught squared. So it equals 8. So in this case, P is 2. So in order to find my focus, which direction am I going to go from my vertex?
2.
To the
Right.
right. It always goes into my curve. So I'm going to go right by P, in this case 2. What coordinate point is that?
-1, +2.
Boom. Well, if I went right for my focus, which direction do I go for my directrix? Starting from my vertex, I go the exact same amount in the opposite direction. So my directrix is this vertical line.
-5.
If you just tell me -5,
Y equals
I
-5.
laugh and count it wrong.
I wrote it down.
I laugh and I count it wrong. Okay, vertical lines. What are the equation for vertical lines? X equals -5, right? The way I remember that is which axis is it touching? X. So X equals -5. Axis of symmetry passes through both your vertex and your focus. So this is a horizontal line. Which axis is it touching?
Y.
So it's Y equals what value?
2.
Boom. Killing it.
Is the quiz gonna like be set up like this, or are you gonna have stuff like the warm up?
It's going to look like this.
Okay, cool.
There's 3 questions like the warm-up. I'm going to treat them as bonus.
Okay.
Can you scroll up to
Treat them as bonus?
Like a little more. Go on the top page. I just lost the go out.
Questions on parabolas? Is that a little better?
Yes, way
Okay. Hey.
Kind of
You
forgot.
have to find, like, she
Oh,
gives you
wait.
the vertices,
I
the
remember.
co-vertices or whatever.
On
and
my
you have to, like,
parabola
plug in.
homework, I put the coordinate of where the directrix and the axis of symmetry like originated from. Is that not right?
Directrix should be a line.
Yeah, but I just put like,
If it doesn't look like this, it's wrong.
let's say like I did it like from here and I ended up here. I just put like that coordinate right there.
That's wrong.
All
It
right.
needs to be a line. All right, one more. I got to get this in before lunch because I'm leaving after lunch.
Why?
I'm taking these kids to a leadership workshop in Hunt, Texas. They get to ride in a van with me for 5 hours.
Sing their ears until they believe it.
Oh, I sing sometimes.
Laura's not coming back.
Unfortunately. I thought going to cancel his headphones now.
Okay.
Yeah, both my headphones are okay.
They're lucky individuals. You know you wish you were going.
All
right. Yeah, we'll be there until Sunday evening.
Oh my.
All right. And it only cost them like almost $300. Okay, here we go. So here we go. Horizontal.
Everything gotta be paid for.
A society who don't pay for anything.
There is the horizontal. Here is the vertical.
See, it just kind of seems like the same thing. Like it's ellipsis, but it's
The only thing is negative. Yeah.
Right? There are two major differences. Actually, because I don't care about A's and B's anymore, there's only two differences between ellipses and hyperbolas. What's the first one?
It's minus.
It's minus. Ellipses are plus. Hyperbolas are minus. The other difference is if it's a vertical, the y has to come first. If x comes first, it's horizontal. Yeah? Yeah. Hi, can I help you? Oh, you're going to be me. Okay, I'll be down here in just a moment. Ooh, that just brought back that instinct. It's going to be me. No?
Yeah.
Okay. Okay, you're with me? All right. Hyperbola. Let's label all the important parts. What is this point right here in the middle?
Center.
That is your center. What are the points on the curve?
Your
Vertices. Yep. Here's a vertex. And here's a vertex. Does anybody remember, I'm not going to quiz you on this, but does anybody remember what that axis is called? No, it's major and ellipses. Transverse axis.
okay.
Right? Your vertices lie on your transverse axis in that direction. Now, what are these points not on the curve called? I heard it.
Vertices.
covered.
Co-vertices. So here's a co-vertex. And here's a co-vertex. Alright, the points, actually they are inside your curve, but they're like outside of like the major happening area. What are these points called?
Focus.
Here's a focus, and here's a focus.
This is the one where you draw a box, right?
This is the one where you draw a box. Stay with me. Questions on that? How can you tell if a hyperbola is vertical or horizontal? When is it horizontal?
X comes first.
X comes first.
X comes first. When is it vertical?
Y comes first.
Killing it.
Hope so.
I don't care about A, B, and C, so I'm not going to answer A and B. What is C?
Square root of
Distance from what to what?
Center to focus.
Center to focus. And what's that formula?
C equals A squared plus B squared
Look here, this is minus, so this is
plus.
plus. All right, what is the process to draw the asymptotes? How do we draw in those asymptotes?
Making a box.
What do we box?
Vertex and co-vertex.
Box the vertices and co-vertices. Draw lines through diagonals. Yes?
Yes.
Oh, I think we're gonna make it.
Where'd your clock go?
I took it out by my phone.
Oh.
I wanted it that way, so all you had to kind of like break your neck to look at it, you know.
It's horrible.
All right. Let's get an example in.
Bless you.
Bless you.
God bless you, Mackenzie.
Right off the bat, I know what kind of hyperbola this is. What kind of hyperbola is this?
Horizontal.
How do you know?
X is first.
The x comes first, so it's horizontal. That means when I'm done, it better look something like this. Right? It's going to look like that kind right there. Okay? Again, I don't care about A and B. Mark them out. I don't want you getting hung up on, well, what is A in this one and what's B in this one? I don't care what the letter is called. Let's talk about our center really quickly. Careful, do not let me trick you in hyperbolas either. What's my center?
3, negative 2.
Negative 2. Right? And this one, if the Y were on the left,
It'd be
opposite, right? But that's a place that I'm going to be able to get some of y'all on the quiz and the test. Don't let me get you.
And don't try to get
Oh, I'll try. I'll try. I'm coming for you.
Oh, darts.
All right. Let's graph this guy. 3, 1, 2, 3, negative 2. There's our center. Now, traveling left or right, where am I looking for left and right?
Bigger number.
I don't care if it's bigger or smaller. It's
X.
underneath the X, right? X travels in the left and right direction. So how far am I traveling left or right?
3.
3. And vertical movement goes with which variable?
Y.
So how far am I traveling up and down?
4.
4.
Up 4, down 4. Yeah? Yeah. Okay, let's calculate C. So in this case, it's going to be 9 plus 16, right? Take the denominators, add them together. Well, what's 9 plus 16?
25.
And what's the square root of 25?
5.
Right, we didn't even need to know that. That was your Pythagorean triplet, 3, 4, 5. Y'all should know that from like 7th grade. All right, so from my center, I'm going left 3 points, 1, 2, 3. And I'm going right 3 points, 1, 2, 3. Isaac, or Ivan? Did it again.
I messed up. You're good.
You with me though?
Yeah.
Okay. Vertical movement. I'm going from my center up 4, 1, 2, 3, 4. And down 4, 1, 2, 3, 4. All right, once I get those points drawn, what do?
Draw a box.
I draw a box so that all of those points touch the box. Made me think of Finding Nemo. He touched the butt. They have to touch the box. Right, okay, anyway. All right, you're with me again. Okay, this guy, he gets me. Okay. What is the point of the box?
To draw diagonals.
Draw a diagonal asymptote. So from corner to corner, with your student IDs, because you all have them on, and if not, get them on.
or use a Starbucks.
Nope. I have my ID on, girls.
They still haven't given me mine.
You still haven't gone to get yours.
No, I did. I went to the office. They said, we're still getting all the seniors in. I'm like,
Steven, nobody even checks it. Not even the K-Cal people check it.
Miss Cleveland does.
they didn't print mine. I swear, like, I went down to the office and they're like, yeah, we'll call you down when it's ready.
We'll go check. Be proactive. Be a leader. All right. Now, this is where you need to go back to the beginning of the problem and say, okay, which way was I supposed to draw this again? Because it's horizontal, it's got to look like this. So remember, you're going to get very close to your asymptote. You're going to pass through your vertex and get very close to your other asymptote. There's my left side. Go to the other side. Get very close to your asymptote. Pass through your vertex. And get very close to your other asymptote. Boom. Now, which ones are my vertices? Up and down or left and right?
Up and down.
Left and right.
Left and right, because they're the ones that actually pass through your curve. So what's the coordinate points there?
0, negative 2.
0, negative 2. And
6, negative 2.
6, negative 2. Is everybody with me there?
Yes, ma'am.
Mackenzie, you with me?
Yeah,
Huh. Really? Okay.
I am.
Co-vertices. What's my coordinate points for co-vertices?
3, 2.
3, 2,
3, negative 6.
Negative 6.
and 3, negative 6. Now we gotta go put our foci on there. Which way are my foci gonna go this time?
It's going to go outside.
It's going to go inside my curves, right? So in a horizontal, they go left and right. So starting from my center, I'm going to go left 5. 1, 2, 3, 4, 5. And starting from my center, I'm going to go right 5. 1, 2, 3, 4, 5. So what are those coordinate points?
-2, -2.
And
8, -2.
boom. All right, after lunch, you will be taking your quiz. So if you want to take that and study it, that's fine. You do not get to use that on the quiz. The only thing you get to use is this.
Thank you for that.